Let's do revision for this chapter. You learned this chapter in Form 4, Graph of Motion. Now, let's try this question. Diagram 5 shows the speed time graph for the journey of a car. Given the distance traveled in the first 18 minutes is 6 km. Okay, this is very important. We look carefully the graph given and determine the what is represented by the vertical axis and the horizontal axis. So this is time taken in minutes, and this is speed in kilometer per hour. Okay, so for the first part, we want to describe the motion of the car for the period of 18 minutes to 45 minutes, which means here. Now, when you look at this graph, you will notice that when the time passes, the speed doesn't change, right? So this means uniform speed. Okay, so we can describe it this way. The car move at uniform speed. Okay, so this is the answer for part A. Let's do part B. Calculate the value of m. So this is speed against time graph, right? So you know that if you want to find the distance travel, you need to find the area under the graph, but you need to be more careful. You need to look carefully the unit. So this is kilometer per hour, but this is in minutes. Therefore, what we need to do is to change all this to hour first. So later, easier for us to find the distance travel. So how do we change this minutes to hour? We just divide this number by 60, right? 18 divided by 60, 0.3. So this is 0.3 hours. Okay, do the same thing for the rest. 45 divided by 60, you will get 0.75. 54 divided by 60, you will get 0.9. Or you can write in fraction. Let's say sometime when you divide it, right, you get a very long decimal. Don't go and round off it. Just change it to fraction. Okay, so this is 0.9. Now, the question tells us that the distance traveled in the first 18 minutes, which means here, is 6 km. So we know that the area of the trapezium must be equal to 6 km, right? Now, how do we find the area of trapezium? Start with 1 over 2, right? 1 over 2, then find the sum of the two parallel sides, which is here and here. This is 9 plus, we don't know this, we want to find the value of m. Time here, the height. So that's why I told you just now, you need to look carefully the unit given here. This is kilometer per hour, this is minutes. So if you times 18, this is incorrect. You need to time 18 divided by 60. Since we already changed it just now, so we can just write 0.3. Or let's say sometime if you do not change it at the beginning, now for this part, you just take 18 divided by 60. We want it to be in hours. Why? Because this is kilometer per hour. Okay, so this is the distance travel for the first 18 minutes, which given by the question is equal to 6 km. Now we just need to solve this linear equation. You can press your calculator 1 over 2 times 18 over 60. You will get 0.15. 9 plus m is equal to 6. Okay, so you can do the expansion if you want, bring in the 0.15. If you don't want, you can just do it this way. 9 plus m is equal to 6 divided by 0.15. 6 divided by 0.15, which is equal to 40. M is equal to 40 minus 9, and m is equal to 31. Once we got the answer, I would suggest you to label on the diagram given, so easier for you to solve the question for the next part. Let's look at part C. Calculate the rate of change of speed in kilometer per hour square. So look carefully the given unit. For the period of last 9 minutes. For the period of last 9 minutes, which means here. So the rate of change of speed, this is acceleration. So if we have a graph speed against time, we find the gradient of the graph. From 31 kilometer per hour to 45 kilometer per hour. And what's the time needed? Which is 9 minutes, right? 9 minutes. So if you want to find the rate of change of speed for this part, you just find the gradient of this part. And you need to be more careful because the unit requested by the question is kilometer per hour square. And this is minute, right? So we need to change it to hours. The rate of change of speed is equal to 45 minus 31 divided by, this is in kilometer per hour, and here needs to be in hour also because we want kilometer per hour square. So you can take this minus this if you don't want. If let's say you do not convert, you didn't convert all this into hour at the beginning, you can just do it this way. 54 minus 45, which is equal to 9. You can just write 9. But this is in minutes. You need to divide this by 60. If you don't want to write like this, you also can write this way. 9 divided by 60. Okay. Now just press your calculator. Uh, 45 minus 31, which is equal to 14, and this one, just let me press my calculator. 14 divided by 9 over 60. Okay, so the answer is 93 and 1 over 3 kilometer per hour square. This is the answer for part C. Let's look at the last part of this question. Calculate the total distance traveled in kilometer of the car for the period of 54 minutes. Okay, so this is speed against time graph. To find the distance traveled by a particle, we need to find the area under the graph, right? So before finding the area under the graph, look carefully the given unit here. This is kilometer per hour, but this is a minute. So you need to convert this into hours. Okay, total distance travel. For this part, we don't have to find anymore because we know it's 6 kilometers given by the questions. Okay, so this is a rectangle. 31 times 0.75 minus 0.3. If you don't want, you can do it this way. 31 times 45 minus 18 divided by 60. Why do we need to divide by 60? Because we want to change it to hours. Okay, now for the last part, this is a trapezium. So to find the area of a trapezium, always start with 1 over 2 multiplied by the sum of the two parallel sides. This is 31. This is 45. And time the height. Need to be in hours. You can take 0.9 divided minus 0.75 or 54 minus 45 and then divided by 60. But here we know this is 9 minutes, right? Given by the questions. So 9 divided by 60. Okay, just press your calculator. This is 6, just copy. This is 13.95. This is 5.7. Okay, just find the sum of all these numbers. The answer is 25.65 kilometer.